We need to prove z conjugate equals z, and where z is a complex number, if and only if z is real, if z is real. Okay, so first thing that we do is we just define what z is. I'm going to say that's a plus bi, and z is real. So that means we can't have any imaginary numbers in here. So this b must be 0. So then 0 is a plus 0, z is a plus 0i, which means z is a, which means z is a real number. And then z bar, let's look at z bar, the same thing applies to z bar, that b value has got to be 0 as well. So then, since z is a and z bar is a, then that means z equals z conjugate. Okay, so then let's look at this next part here. Now we need to prove it the other direction. If z and z conjugate are equal, then that must mean that those are real numbers. Z and z bar are real numbers, or a is a real number. So first thing we do is set them equal to each other, because that we know is true. And remember the if and only if argument goes both ways. So we subtract a from both sides, then we get this. Then we add bi to both sides, and we get this. Then we just divide both sides by 2i, and we find out that b is 0. And if, since b is 0, then z is equal to a, where a is a real number. So we've already proven it. So we need to show this way. If these are equal, then z is real. And we did that below. And if z is real, then these are equal. So we've shown both ways. Okay. This is 2.1.27.